Is this working? Yes? Okay. Good afternoon, everyone. My name is Ch2. I'm with Open Nuclear Network, a program of PAC Sapiens. Today I'll be presenting some work together with Nikita Dekhtiarev, Marcy Fowler, Sarah Lederman, and myself. And I'll show how modern satellite imagery and analytics can augment the CTBT verification regime, from event characterization to inspection support, using some real test site examples. I just want to acknowledge at the outset that I will be trying to connect this topic as much as possible to the topic of this session, but I am touching on quite a bit outside of it as well. Just very, very briefly about the organization I work for. ONN's mission is to reduce the risk of nuclear weapons use. We do that by monitoring developments that we believe can raise nuclear risks, analyzing and publishing actionable research for decision makers, forecasting through foresight methods, and engaging through trusted partnerships. Okay. I'll cover 4 parts today. At the very first, I'll speak more generally about satellite imagery as a tool for monitoring and verification. Second, how one can monitor nuclear test sites using imagery, and some thoughts on how imagery can supplement and support the IMS and OSIs, and I'll conclude with some key takeaways. So first on satellite imagery as a monitoring and verification tool. Why imagery and why now? In short, growing commercial constellations have made non-intrusive and shareable visual data widely available. Imagery already supports geolocation, incidence assessments, infrastructure and object detection, change detection, and transparency efforts between states and the public. On a whole range of issues. So think about earthquake and volcano disaster mitigation efforts, or IEA safeguards, etc. 2 developments have greatly increased the value for verification specifically in the nuclear space. First, the growing availability, accessibility, and quality of commercial satellite data. And second, the rapid advances we see in analytical techniques and processing power. Together, these factors have made satellite imagery an increasingly operational tool in the broader verification and monitoring ecosystem, with governments, international organizations, and research institutes such as ours, and even news media increasingly relying on insights that are generated through the help of satellite imagery analysis. So for our work, we draw on a variety of different sensor types and analytical techniques. I just want to very briefly highlight 3 main ones that are relevant for our work on nuclear test sites specifically here, but there are more than the ones listed here, of course. So the first one is high to medium resolution optical imagery that is very useful for area monitoring, geolocation, detailed interpretation, and change detection at known sites. So this is ideal for recognizing man-made features or delineating linear features in a very intuitive fashion. Second, multispectral, hyperspectral, and thermal infrared imagery can extract additional surface property information, and where appropriate, identify possible thermal emissions from human activity. A third is so-called synthetic aperture radar, or in short, SAR data, which we use for wide area coverage, very precise change detection, and surface deformation assessments, irrespective of cloud coverage and sunlight. So now I'll be talking specifically about monitoring nuclear test sites. What are some key applications? Before a test, imagery allows us to track infrastructure changes, detect excavation or surface deformation, and identify specific observables such as drilling towers, additional roads, cables, or the growth of spoil piles. After the test, we look for surface deformation signatures in particular. So things like subsidence craters, spellations, rock slides, or avalanches that may be indicative of some seismic event, as well as vegetation damage or any kind of unusual human activity. So in short, imagery, I think, can play a highly complementary role in the existing verification regime, in that it can strengthen assessments both before and after a test occurs. We are very conscious about limitations. Activity interpretation can be ambiguous without a long time series or additional supporting information corroboration. New instrumentation or procedures at test sites can be very different to what we know about the conduct of testing from the previous testing era. So that changes what we'd expect to see. Low yield, deeply buried, underground events can produce, very subtle or no visible surface cues. And our confidence is very much bounded by the constraints we still have with sensors that are very much, still in space and very far away. So distinguishing what's normal and abnormal, or just an artifact of the imagery, can sometimes be difficult. So I think that's the case with any kind of monitoring relevant sensor data. We should also consider imagery always as part of a kind of multi-source analytical process. I won't get into this into great detail today, but we at ONN are continuously monitoring and assessing what we observe at different test sites. Please feel free to scan the QR code for an in-depth report, or please feel free to reach out to me after the presentation. I have some printout copies as well of a recent report. But in short, what we're seeing across different sites is that these are being actively maintained and modernized and appear to allow for a resumption of testing should there be a political decision to do so. And through the kind of work that I highlighted before, we're able to pinpoint to specific areas where we see heightened human activity that then allows us to monitor those more closely and keep an eye out for any activity that may be indicative of possible preparations. So what role could satellite imagery play for the CTBT after entry into force? And I'll now connect a bit more to the topic of this session. First, I think it's worth emphasizing that at present, satellite imagery is not an explicit component of the CTBT's verification regime. However, the treaty itself anticipates additional monitoring technologies. Article 4, paragraph 11 calls on states parties to cooperate in improving verification technologies and to examine the potential of added techniques, specifically calling out satellite monitoring with a view to specific measures that can enhance efficient, cost-effective verification after entry into force. So I think satellite imagery, especially with the kind of improvements we've seen over the past 2 decades, squarely fits into that mandate. What I will show in the following slides are just some visual examples from some of the test sites we look at and possible roles that satellite imagery can play within the broader verification process, some of which may be undertaken by the organization itself or by external parties, such as states that are already doing this, or individual research institutes. So what you're seeing here, I'm not sure how visible it is in the back, but what you're seeing here is a multi-temporal synthetic aperture radar data composite of a site on the island Novaya Zemlya in the Russian Federation, which shows how radar time series can highlight changes in surface deformation with a very precise level of geolocation. Products like these can visually complement potential IMS detections, provide intuitive context for consultation and clarification processes, and where appropriate, support an OSI request by pinpointing to very specific areas of interest. During a possible pre-inspection phase, this example of Lop Nur in the People's Republic of China shows how wide area optical coverage, like the one shown here, can help characterize distinct sub-areas of a very vast territory, delineate possible testing relevant zones, and familiarize an inspection team with the terrain that they will be seeing once at the location, understand access routes and features even before deployment. I think this kind of logistical support role has already been envisioned since at least the IFE in 2014, this in this kind of role can directly support logistics, search design, and work prioritization. At this site shown here, Pungari and the DPRK, we captured signs of personnel activity and restored entrance at a known test site with very high resolution optical imagery. So imagine during an actual inspection, products like the one shown here can aid an inspection team's orientation and navigation at a potential explosion site and help, for example, overflight plans by setting expectations on the possible observable objects and equipment. At this example showing the P-tunnel at the Nevada National Security Sites in the US, before and after imagery following a chemical explosion test in 2023 can show some equipment movement that occurred before and after this chemical explosion test. And such time-stamped visuals like these can add any analytical and communicative value in inspection, after inspection during the reporting phase. So to help the technical and policy audience to better understand what happened, where it happened, and how it happened, and how it aligns with other available sensor data. Thank you. So in conclusion, I have 3 main takeaways. The first one, commercial satellites and advanced analytics have matured to the point where imagery is now a reliable, non-intrusive, and easily shareable source of CTBT-relevant indicators. Second, imagery adds practical value throughout the verification cycle. So before, during, and after possible future OSIs by supporting site characterization, inspection planning, and post-inspection reporting. Third, our assessment shows that currently test sites remain actively maintained and modernized, and from our point of view, the verification regime more broadly benefits from transparency provided by states, international organizations, and the research community more broadly on the nature of the activities that we see at these sites. And imagery can play an important role in strengthening that transparency. So thank you. If there's any time, I'm happy to take any questions or after this session. Thank you.
Thank you, Dr. Zhao Sheng. So the floor is open for any questions or comments. So please. Hello, Julian from Hong Kong University of Science and Technology. Thank you for your talk. I have two questions, actually. The first question is, so you talk about markers or signatures that betray some abnormal or illegal activities. And I think you make assumptions on what should be those signatures, like a crane, excavation, etc. But did you also use empirical data on actual tests that has happened in the DPRK to enrich the type of markers that we should look at? Because it's not always evident what type of markers or signature that we should look at. Second question, and I guess it's an obvious question from my side since it's my research, but have you looked at typical activities that are conducted for subcritical, very low yield tests? Is it something that you also can detect or gather? Thank you.
Thank you for can I, yeah, okay. Thank you for the great questions. To your first question, I think it's a very important issue because we don't have more tests than we wish have happened, but they have all mostly happened quite a long time ago, right? And the available imagery to us doesn't date back necessarily as much as where we have that large sample of testing, right? And you mentioned the DPRK test site, so that, and the tests that have occurred there. So for sure, that's imagery around the tests that have occurred there is something that we've looked very closely at and to try to better understand indicators more broadly. But I think I made this point during the presentation as well. The kind of equipment and procedures, the time span, etc., that's required and used in any future testing may be very different. So there's definitely a big source of uncertainty in that kind of work to us. Yeah. And you mentioned subcritical tests, and I think that very much connects to that first question on how much things have changed, right, compared to the previous few decades. And the short answer is probably no. I mean, we know about some dates, not exactly the precise dates, but we know about some date ranges of when subcritical tests have occurred in the United States, right? So we look at the kind of activity we observe above U1A to see if heightened activity corresponds to when we know a test actually occurred. But I think, and maybe I'm happy to discuss that further afterwards. But it's very difficult and probably not possible. Yeah, thank you.
Any more questions? So please.
Vladimir Krychenkov, Russia, former OSI director. My question is on applicability of the satellite imagery. These technologies allowed for member states for request, for consultation clarification, for pre-inspection. But the inspection team itself is not allowed to use this technology. And in practical life, as I know, there might be many reasons to request an additional satellite image of the area. For example, the location of ground zero is uncertain, or the activities were far from the event. So what do you think? How to, we cannot solve it, but how you can advise for the inspection team if they are not allowed? You understand the question?
I think so. I think you made two very good points on the potential roles of satellite imagery, and that the organization may encounter imagery that's provided by state parties during a consultation and clarification process, right? And the organization itself may not have the capability to acquire additional imagery, even though it may very much make sense for inspection planning and so on. And I think at the end of the day, that's maybe more of a political question. But I think nonetheless we should have an awareness of and good understanding of what the potential capabilities are, how reliable they are, and what the limitations are. And then even for the CTBTO, the inspection team, even if they're not able to task imagery themselves, to understand imagery that's provided through open source information or through state parties, to understand what they're seeing there is, I think, still an important issue. Yeah.
Do you understand that it's a strong recommendation for requesting party? Just if they are not capable to provide detailed information on certain, they may have to consult other states and see. And I can give you an interesting example. Field exercise in 2000 in a former Kazakhstan test site was implemented with an easy signatures of the ground zero where the chemical explosion was exploded. But the inspection team was misled with many other signatures of different, because it's tested different boreholes, tunnels, and so on. And finally, they were not able to find the ground zero. Strange, but it happens. It's shortly written in the annual report 2001, as I believe. So that again, and just having the image of existing nuclear test site, you can see so many different features which could be related to the test. So again, it's the requesting state should be very careful in explanation and satellite imagery interpretation, I think.
Thank you very much. Yeah.
Okay, so thank you both for the excellent interactions. With that, we thank